Welcome to the Crawford's Computers booking and scheduling system. Our system manages almost every aspect of our business, but the most important is our booking and scheduling system that integrates our technicians' Google Calendars with our system. Our integration with Google Calendars is an extremely important feature of our system. It allows us to manage the daily schedules of our technicians, accommodating both other work events and each technician's private availability, especially considering some technicians are contractors, with a mix of private and work events during any given workday. This feature helps avoid scheduling conflicts and allows technicians to easily flag their availability on their private devices and have this information available to our scheduling system within a few seconds thanks to the use of webhooks, allowing for almost real-time calendar updates into our booking system. In this video, we will demonstrate the following processes. 1. How to authorize and integrate a new Google Calendar with OAuth2. 2. How to book and reschedule an appointment. 3. How users can revoke access to their calendars. 4. A brief overview of the main calendar interface. 5. How we store access and refresh tokens. Part 1. Adding a new calendar. We have developed an easy-to-use and secure OAuth2 self-service website that allows users to effortlessly add their calendars to our booking system without logging into our main system or needing help from a supervisor. This system can be accessed through our public website, enabling staff to use it both from home and at work without any restrictions. The system is designed specifically for staff use and is clearly labeled to discourage customers from adding their calendars. However, if a customer does add their calendar, it won't appear in our system because it cannot be linked to a staff user account. Let's run through the process of authorizing and adding a calendar. The first step is for the user to select the access level they wish to grant to our system. Next, users click the link button where they are prompted to sign into their Google account. In this video, the account I am using is known to my browser, so it is listed and knows the login details. However, normally, a user would enter their email address, password, and complete any multi-factor authentication required by their account before proceeding to the next step. Ignore this unverified app warning. It won't show to users when the system goes live and Google has verified our app. Next, users agree to give access to their user profile, email address, and profile photo, and click Continue. Next, users must agree to allow our system access to the requested scopes, which are detailed under. This will allow Crawford's network too. The user clicks Allow to continue and is taken back to our website and shown a success message if there were no issues. This step requests that users sign into their staff user account with their full password and a code from their Authenticator app, which will link the new calendar with their staff account. Any calendars added to our system that aren't linked to a staff account are not displayed in our system, and if they remain unlinked, are deleted from our system after 30 minutes. In this case, we have a successful link. If a user revokes our access to their calendar and wishes to reauthorize it, the subsequent reauthorizations do not require linking to a staff account again. Our system keeps a record of all linked calendars and their associated accounts. Despite being hosted on a public website, the security of our system is robust. Designed to ward off potential misuse by malicious entities, we employ several security measures, including HTTPS Strict Transport Security, HSTS, the use of nonces and anti-CSRF tokens, a strict content security policy. We block the framing of our site with X-frame options, among many other practices, making the site as secure as a public site can be. That said, even if a successful attack were to take place, there is no monetary or other value in any information that a hack could possibly extract from this site, as it is basically sandboxed from the rest of our booking system specifically for this reason. Now let's explore how new appointments are integrated into user calendars using our system. I start by entering the customer's details and all necessary job information into the booking form. If the customer has a preferred technician, I select them, then scroll through the calendar to locate an available slot for the booking. After selecting the slot, I confirm the details, time, and date with the customer, then click the Book button. The user then reviews any alerts, such as potential surcharges, and finalizes the booking. This process automatically adds a new event to the technician's calendar, which includes all relevant customer contact information, job details, and booking information. This information appears on the technician's Google Calendar within a few seconds, eliminating the need to phone or message the technician about the new job. It also removes the need for technicians to call the workshop for job details if they are not near a computer and cannot access our system. As demonstrated, I've scheduled this job for 12:30 p.m., and the customer will be charged a travel surcharge to cover the time and costs of traveling to the job site. Now let's imagine the customer needs to reschedule their appointment to 4 p.m. The user can simply drag the appointment on the main calendar to the new time slot. If the appointment needs to be assigned to a different technician, and thus move to another calendar, the user can click on the appointment, double-click the calendar name, and select a new calendar from a drop-down list that shows only those calendars to which the system has write access. Changes made to the event on the calendar sync in real time with Google Calendar. Similarly, if there are updates needed for the user's name, email address, or other details after booking, these can be adjusted directly on the calendar, and the updates will reflect on the technician's calendar. Technicians use their Google Calendar app on their phones to access the address and booking details. Link the address to Google Maps for navigation, and review all necessary job information before arriving at the job site, eliminating the need to log into a web portal or call the workshop for details. To revoke authorization for our system to access the user's Google Calendar, they must first log into their Google account through a browser. This can be done on any device, then navigate to their Google account page. Select Security from the menu on the left and scroll down to Manage Third-Party Access. Then they should move to the Your Connections to Third-Party Apps and Services section. Click on See All Connections and find the Crawford's Computer Service entry. Click on this entry, scroll to the bottom of the page and select Delete All Connections. Finally, they must confirm the action by clicking Confirm on the Google warning prompt. At this point, our system will no longer have access to the user's calendar, even if the access token still exists, as the token is now revoked and rendered ineffective. If or when the calendar is reintegrated into the system, the user will need to re-authenticate, at which time Google will issue a new token. Let's explore the main calendar page used in our system. As you can see, it resembles the Google Calendar interface, which we've modeled to make it familiar to users. After all, Google has perfected the UI, so we've adopted a similar design. On the left side of the page, you'll see a list of calendars divided into two categories: those with write access at the top, and read-only calendars below. Events won't be added to read-only calendars. These are used mainly to display users' availability when scheduling new jobs. Users may link more than one calendar to the system, but only one can be designated to receive new bookings. Each calendar has a checkbox next to it that users can click to view or hide its events. Below these options, there is a Deleted Events checkbox. Clicking this will display any deleted events for the selected calendars. Users can restore an event by clicking on it, and then clicking the Undelete icon in the pop-up window. Technically, the event isn't restored in the traditional sense, as the Google API doesn't allow reuse of event IDs or methods to restore events. Instead, our system clones the cached event to a new one with a different ID, effectively restoring it from the user's perspective. All calendar events are loaded from a local database. We use a CLI PHP script that runs behind the scenes, listening for webhook notifications about changes to calendar events, downloading these from the calendar servers, and saving them in our database. This enhances the user experience by making it faster and reducing the number of API calls to Google. In the event list, any calendar showing an alert symbol indicates that the access token has been revoked or expired. This means users will not see new events for that calendar, nor will they be able to modify existing events, though they can still view them in read-only mode. The calendar displays a week from Monday to Sunday. Users can navigate to the next or previous week using the left and right arrows at the top of the calendar grid. For faster navigation to a previous month or year, users can use the Mini Calendar Navigator. To add a new event, users click on an empty space, enter the event title, and once the placeholder changes color, it's saved. Users can move the event to another calendar, excluding read-only ones, change the time manually, or by dragging the event to a different spot on the calendar. By default, events on all calendars appear as busy, unless the event was generated by the system or the calendar belongs to the logged-in user. If users with busy and read-only access view their calendars, they will still only see busy. However, if they granted read or read-write access, they can view the details of their private events while other users still see busy. Finally, as shown here, Our PHP scripts encrypt JSON-encoded tokens and refresh tokens before storing them in a local MySQL database. Additionally, the connection to the database employs SHA-2 password encryption and SSL certificates to secure communication between the scripts and the database. User credentials are exclusively stored in encrypted databases on the server side, avoiding the use of cookies or client-side storage. They are also verified with every PHP script call by the user. When users log in, their session ID and a unique token with a limited lifespan are generated. This token is refreshed whenever the user re-enters their password or PIN during the session. Our system mandates full password re-authentication every 3 hours for LAN users and every 30 minutes for sessions from remote locations to thwart the use of devices like mouse jigglers that keep sessions active without actual user interaction. User credentials or sessions can be remotely revoked or terminated immediately, even if we no longer have access to the device initiating the session. The system also monitors changes in IP addresses during a session. If an IP change is detected, the user must re-enter their full password, safeguarding against session hijacking, which typically involves an IP change to the attacker's IP. If the IP shifts from a trusted to an untrusted location during a session, the user's session access is adjusted accordingly. This security measure prevents users from maintaining high-level access when they leave a secure office Wi-Fi environment for a less secure one, like a mobile device or a customer's laptop, and restrict staff from accessing the system from unauthorized remote locations. Thank you for viewing our demonstration. We hope that the video has given you a thorough understanding of how our system works with Google Calendar. Our focus on security, user accessibility, and smooth integration underlines our dedication to delivering quality. We are dedicated to continuous enhancement and to following best practices in all facets of our technology, particularly in areas such as system security, user privacy, and the development of intuitive and accessible user interfaces. Should you have any questions or require additional information to make a decision on our project, please do not hesitate to contact us. We value your consideration and are eager to discuss the next steps for our OAuth2 calendar integration. Once again, thank you for your time and attention.